Hey everyone, welcome to distance learning lesson number 9. As you can see, today's lesson is going to be done in a little bit of a different format than I've done in the past. So you're going to be following along on this kind of PowerPoint presentation. You're still going to be taking notes in a notebook, and hopefully this method will be a little bit more engaging and less boring than just looking at my blank iPad screen. You can see my little face in the corner here. Not that that's supposed to provide you anything other than some human interaction, kind of, during these weird times. So yeah, I hope that you guys find this method a little bit more enjoyable, and let me know if this is working better for you than the other videos that I was posting previously. Yeah, I put a lot of effort into the aesthetics of this video, so hopefully this makes distance learning suck a little bit less. Okay, so this is lesson number 9. Today we are continuing with volume, still in the geometry topic. So last video you guys watched a introduction to volume and kind of like visual representations of how we can understand volume when we're dealing with 3D shapes. Up to this point, everything we've dealt with have been in 2 dimensions, so 2D shapes. And now we're dealing with 3D shapes. So instead of it just being a square, it's now a cube, right? It has 3 dimensions. Rather than just having a length and a width, it has a length, width, and a height. That's 3 dimensions, okay? These are more like the shapes that we see in real life, right? So imagine like a 2D shape would be you just like maybe like drawing on with, let's say you're drawing with chalk on the sidewalk and you draw a square. That's just 2D, right? But if you bring something to real life, if you make it an object like a box or a dice or a lot of other like containers that you can think of, now it has 3 dimensions. You've also added that depth to it. You could put stuff inside of it. That's 3 dimensions. And that's really what we're more interested in the real world, right? Because that's everything. We exist in a 3D world, right? So things have depth and they have length and width and height. And so so it's actually a lot cooler to be able to calculate geometric topics with 3D shapes, okay? So today, lesson objective. So these will be the things that you're still taking notes on in your notebook. So today, I will be able to find the volume of a cube. So pretty straightforward. In the lessons that you watched, the Khan Academy ones, they kind of went through like what it visually looks like. Today is going to be more just about plugging in numbers and figuring out what the actual measurement of volume is. Okay, so take a moment to write that down. At any point, if you need to pause to write, please do that, okay? All right. So let's warm up a little bit. So answer these questions in your notebook. Number 1, what is volume? Okay, what do you remember from the last couple videos that you watched? What is volume? And secondly, what is a cube? Right, because today we're talking about the volume of cubes, so we need to know what cubes are. Okay, again, pause the video, take a second to write that down in your notebooks. All right, so after you've done that, let's review your answers. So number 1, what is volume? Well, volume is just a measure of the amount of space that a solid occupies. So solid meaning like a solid shape, like a dice, for like a pair of dice, for example. Okay, so how much space is inside of that shape? How much space does it occupy? That's what volume is measuring. Okay, so if you're thinking about like an empty box, the question is, how much could we fill that box? Okay. And a cube, hopefully you remember, is just a 3D shape that has 6 identical square faces. Okay, so a square is 2D, and then if you make it 3D, then it becomes a cube, okay? But on a cube, each face is a square, right? So it's very similar to a lot of the properties that we have for squares, okay? Okay, so this is kind of the bulk of what we're doing today. So it's all about how to find volume. So that's what you can like title in your notes, like how to find volume. Okay. So today we're talking about how to find volume, but that's specifically for cubes and rectangular prisms. Okay, rectangular prisms, we'll talk about it next time, but it's the same concept. That's like the 3D version of a rectangle. And then cubes also is like the 3D version of a square, right? So what we're learning today with volume applies to those shapes. When you are dealing with different shapes, you use different ways to find volume. Don't worry about that for now, but just know that this is how to find volume specifically for these shapes and not for any shape ever, okay? So, volume, as I said, is for three-dimensional shapes, right? So, when we were dealing with area, it was just length times width, right? All we're doing with volume is adding in that third dimension of height. Okay, so this is the formula to find volume in general for cubes and rectangular prisms. It's volume is equal to length times width times height. And again, we're dealing with three dimensions here. Three dimensions because volume deals with 3D shapes, okay? So we have a dimension for length, we have a dimension for width, and now we also have a dimension for height, okay? Now, today we're specifically talking about cubes. So actually, we can take this volume formula and make it even more simple for cubes specifically. Okay, so cubes, and again, this is something that everything that I have written on the slides is what I would like you to write in your notebook, okay? So cubes are special, right? Because the length, the width, and the height are all the same measure. So just like a square where you have all sides are the same, a cube is just made up of a bunch of squares, right? So all sides are the same. So for a cube, we can write this volume formula a little bit more simply, okay? So volume, again, is length times width times height, but that's all the same for a cube. So a side of a cube, we call it an edge, okay? So I'm going to label it E for edge, okay? E for edge, another edge here, and another edge here. Okay, so I could continue labeling, but I don't need to keep doing it. I know that they're all the same length, okay? They're all the same measurement. So E, again, is just an edge, okay? That's what we call like the side of a cube. It's just the edge. Okay, so volume, instead of saying length times width times height, what that is on a cube is just this edge times this edge times this edge, okay, which is the same measurement, E times E times E, where E is equal to just the length of the edge, okay? So we can write that in even a simpler version, and this is going to be our most simplified version of it. The volume, and again, this is for a cube specifically, volume is equal to E to the third power, okay, or E cubed. Remember, third power is, we call it cubed. Just like second power is squared, third power is cubed. So why is it E cubed? Because remember, that's E times E times E, okay? Just writing it in a more simplified version, we could write it as an exponent because it's the same variable over and over and over again, okay? E to the third power is just E times E times E. So whatever the length of that edge is, we just multiply it 3 times, right? Okay? So whatever it is, you just do it 3 times itself, and that gets you the measurement for volume. Okay? So I know that putting things in variables or letters is kind of more confusing sometimes, so let's look at an example with actual numbers, okay? All right. So example 1 here, I want to find the volume of a cube that has an edge length of 4 centimeters. Okay? So I know it's a cube because it's telling me that. In order to find volume, I need to know the length of the edge, right? Because the formula for cubes is volume, V, equals E. That's really bad. Sorry. Volume equals E to the third power, or in other words, E times E times E. Okay, so I just need to know what E is, and then I can come up with a number. And it tells you that. It has to tell you that. That's information that's going to be given. Okay, edge length of 4 centimeters. So volume, V, equals 4 to the 3rd power. Okay, try to remember back. How do we simplify 4 to the 3rd power? Ask yourself, should I be doing 4 times 3? Or should I be doing 4 times 4 times 4? Okay, hopefully we remember that is equal to 4 times 4 times 4, which is very different than 4 times 3. Okay, 4 times 4 times 4 is actually 16 times 4, which is 64. Okay, so volume equals 64. Now, it's very important here. I can't just leave my answer as 64. That has no meaning right now. Okay, 64 what? I need a unit, centimeters. It gives me that. 64 centimeters. Okay, remember how for area we always had to put squared, like centimeters squared, the little 2? For volume, I have to put the little 3 because volume is in 3 dimensions, okay? So it's cubed. 64 centimeters cubed. Okay, so it's 4 centimeters times 4 centimeters times 4 centimeters equals 64 centimeters cubed. Okay, so we just started with the general formula up here. We started with the general formula. We plugged in what they're giving me for the edge length, and then we're simplifying. Okay, if they wanted to, or if I wanted to, I could have given it to you as a image of this cube. If you're wondering how to draw a cube, I'm not too concerned about your artistry, but what I like to do is just a square and then another square kind of overlapping it like that, and then connecting the lines together. It makes a 3-dimensional shape of a cube. Okay, if you're not great at that, don't worry. You can ask your art teacher, Miss Learn, to help you out. Okay, so what this is saying, the edge length of 4 is just saying this is 4, this is 4, and this is 4, right? 4 times 4 times 4. That's all we're doing. All right? Hopefully that is not too bad. Make sure you're taking notes. Okay, let's do another one. Find the volume of a cube with an edge length of 8. So same thing, just different numbers. Okay, again, you do have to know what the formula is. So remember, the formula of volume is equal to, try to remind yourself before I tell you, e to the what power? To the 3rd. E cubed, right? Volume equals e cubed. Volume equals, I know that e is 8. Cubed. Okay? So, volume, that was really aggressive. Okay, so I'll give you a second to do that on your own. Try to come up with an answer. I'll do it off to the side to you. I don't have a calculator in front of me, so I'm actually going to do this with you guys. Remember, 8 cubed is just 8 times 8 times 8. So I know that 8 times 8 is 64 times 8. $512. Now, hopefully you guys got the same answer. Let me just check my math really quick. 32, 48, 51. Yeah, 512 what? If we're dealing with feet, is that my final answer? No, because volume is in 3 dimensions, so I need cubed to the 3rd. Okay? All right, next one. All right, only difference here is that instead of telling you the edge length is this, I am giving it to you in a picture. So the thing with cubes is that they're not going to tell you every side because every side is the same, right? So if this is 6, that makes this also 6, that makes this also 6, right? That is the definition of a cube. All edge lengths are the same. Okay, so volume equals 6 times 6 times 6. Okay, remember that's very different than 6 times 3. That's probably the biggest mistake that people make here is they want to do 6 times 3. But really, it's 6 times 6 is 36 times 6 is another 36 here. 18, 20, 21. Okay, so volume equals 216, and I always need my units, centimeters, cubic centimeters. So the way that we would say that is like 216 cubic centimeters, or 216 centimeters cubed. Okay? Cool. Again, pause the video if you need to look back on this. Let's do next. Okay, this one is a little bit trickier because we're dealing with a decimal here. Okay, I'm going to give you guys the opportunity to do this one on your own. Okay, so pause the video, do it on your own before I show you. Okay, so hopefully you were able to see that volume is equal to 3.2 times 3.2 times 3.2. Again, it's the edge times the edge, which is also 3.2, times the edge, which is also 3.2. They only gave me one measurement because I know that for a cube, they're all the same, so they don't need to repeat it every time. Okay? 3.2. I really wish I had a calculator in front of me, but this is good practice. Try not to use a calculator on this because it'll help you practice multiplying decimals. Okay, so 3.2 times 3.2, and then I'm going to do it again after I get this answer. So 4, 6, 6. Oh, I need a 0 placeholder. 6 and 9. Adding those up, that gives me, I'm going to move it over here, 4, 12, carry the 1, 10, 24, and I have 1, 2 decimal places to move, so it goes right there, times another 3.2, right? Okay, so that's 8, 4, 0, 2, and placeholder 7, 0, 3. It's a 0. Okay, so that would give me a final answer of 8, 6, 7, 2, and a 3. Okay, I have 1, 2, and 3 decimal places to move. So 1, 2, 3 puts me right here. 32.768, and that is going to be cubic feet this time. Again, I'm getting that feet from here, from the problem itself. So volume equals 32.768 cubic feet. Okay, sorry for my extremely ugly multiplication, but hopefully we're getting the same answers. Okay, cool. Next one is your exit ticket. So hopefully this lesson wasn't too bad. So all you have to do now is in your notebook answer these 3 questions. What is volume? What is the volume formula for a cube? And then find the volume of a box with an edge length of 5 feet. And I'm assuming that this is a cube-shaped box, okay, not a rectangular shaped one. So it's cube, meaning all sides are the same, all edge lengths are the same. Okay, take a moment, please pause the video and try it on your own before I give you the answers. This is your exit ticket, so hopefully we have got this down by this point. Okay, so let's reveal the answers here. So the volume, what is the volume? It's just a measure of the amount of space a solid occupies. So That's kind of the fancy way for saying like how much space is inside. Okay. What is the volume formula? So just general using exponents, V equals e to the third power. Okay. E cubed. And then what is the volume of a box with an edge length of 5 feet? So hopefully you were able to do volume equals 5 cubed. Cubed. Okay, which is the same as 5 times 5 times 5, which is equal to 125 cubic feet. Okay, so the volume of that box would be 125 cubic feet. All right, very different than 5 times 3. Remember, make sure for exponents we're writing it out, okay, so that you don't make the mistake of doing 5 times 3. All right, that's it for today. Hopefully that wasn't too bad. So after you've watched this video, go ahead and do the lesson 9 assignments. Leave comments. Tell me if this method works better for you, or if you prefer the old method with the iPad. I hope that this is a little bit better, a little bit more fun for you guys. Okay, so please let me know if you've watched this video in the comments, and have a good rest of your week. I will see you guys in the next one.